Hi, in this lesson, we're going to start Theme 6. So you're going to need your Theme 6 booklet, the one with the purple cover. Okay, let's go. This theme is a relatively short one. We've looked in a great deal of detail at sedimentary rocks. We've also studied igneous rocks, and it's now time for us to get stuck into metamorphic rocks. Now, we're not going to dive as deeply into metamorphic rocks as we've done with some of the other kinds. Metamorphic rocks can get very complex very quickly. So we're going to look at some of the basic ideas behind them and learn how we can both identify these rocks and interpret them. Okay. As ever, if we're starting a new theme, we need to address some of the key terms. So I'd like you to turn to the inside of the back cover of your Theme 6 booklet and write down what you think these words might mean. Some of them you'll come across before. Others, like that one, perhaps not. Some of those words will have a meaning perhaps outside geology. But I want you to write down what you think each of those mean. Have a go at that now. Okay then, this does beg the question, what is a metamorphic rock? What makes it different from the igneous and sedimentary rocks that we've already been studying? And I think the best way to illustrate that is to have a go at the starburst experiment, if you haven't done so already. But from that then, we need to think about how we can actually recognize a rock as being metamorphic. What features could we recognize that let us pick up a specimen of this and identify it as being of metamorphic origin? These are the 5 rocks that we need to know. Let's have a look at how we can recognize them. What are their key features? These are the 5 metamorphic rocks that we need to be able to recognize for GCSE Geology. You'll find pictures of these on page 3 of your Theme 6 booklet. We have slate, which is specimen U. We have schist, which is specimen W. We have gneiss, which is specimen H. We have marble, which is specimen I. And finally, we have metaquartzite, which is specimen X. What we need to do is look at these rocks and try and work out some of their key features. So let's work through them in turn. Let's start with specimen U. Now, specimen U is a very, very fine-grained rock. It's not possible to see the grains within this rock. They're just too small. It's quite dark in colour. In fact, it looks a little bit like a shale or a mudstone, except the specimen U is much harder. Also, if we look at specimen U from the side, we can see that the grains within this rock are aligned. Now that means that this rock can be split into parallel sheets along these planes of alignment. We call these cleavage, like in a mineral. But it means that because this rock is metamorphic, so it doesn't have porosity or permeability, and the fact we can split it into these thin parallel-sided sheets means we use slate for a roofing material. Specimen W then, schist, is different in appearance. In this one we can see crystals. In fact, there's very distinctive flat, sort of flaky crystals that are mostly sort of silver in colour. There are some darker coloured ones though that are also quite flaky. In addition to that, there are some colourless minerals in here as well. But the key mineral is this flaky one. If we look at specimen W from the side, again we can see there's an alignment of these crystals. And this alignment is picked out by these sheets of this silvery coloured mineral. This rock is schist, and we describe this alignment of these flaky minerals as schistosity. Specimen H also shows an alignment. But in specimen H, this alignment is shown by bands of different coloured minerals that are all roughly parallel to each other. We have some darker coloured bands that contain a black vitreous mineral, and the lighter coloured bands then have a mixture of a white and pink mineral. If we look carefully down at the bottom here, we might just be able to see has two planes of cleavage. There are also some of the colourless hard minerals within these lighter coloured bands as well. But this rock is completely crystalline. In fact, we need to be careful we don't mix it up with a rock like a granite. But the key distinctive feature that shows us it's not granite are the fact that the minerals in here aren't random, that there's an alignment, there's these bands that we call gneiss banding, because this rock is gneiss. Specimen I and specimen X are actually both fairly similar. They're both white or very light in colour. They both have what we call a sugary texture. So we can't see any alignment of the crystals within these rocks. In fact, they both just look like broken bits of sugar cube. Now there is a way though of telling these two rocks apart. Specimen I is marble. And if we take some hydrochloric acid and we drop some hydrochloric acid onto this rock, you might be able to see there it reacts, it fizzes. Now that tells us which mineral makes up this rock. If we do the same test on specimen X here, on the metaquartzite, now its name gives us a clue what's in this rock, but if I drop some acid on this rock, it doesn't react. Specimen X is also much harder than specimen I. So what minerals do you think make up these two rocks? We know they look very similar, but they're clearly made of different materials. So for each of these rocks, can we now describe some of the key features of these with each of the photographs that are shown on page 3 of your Theme 6 booklet. Okay, having seen those descriptions, what I'd like to do now is pick out what the key features of each of these rocks actually are. Write those underneath the photographs that you can find on page 3. If you need to, rewind and watch that section of the video again. Press pause now and have a go at that. Okay then, so we've seen some of the key features of metamorphic rocks. This alignment and some of the minerals that we form within them. But there are 4 things that actually control metamorphism. It's one of the reasons why metamorphic rocks are a bit more complex than other types of rock. We've got more things going on, more variables that might affect the rock that we actually finally see. These are some illustrations of these 4 things. You'll find these on page 4 of your Theme 6 booklet. The first one we need to consider is heat. And that can be the source of heat as well. Is it heat from deep within the earth? Or is it heat from being close to a large igneous pluton, for example? So the amount of heat applied to a rock will have an effect on how much metamorphism there is. The second factor that has an effect is pressure. How much pressure has the rock been subject to? Now, if that's deep within the earth, heat and pressure will go together. If it's at a shallow depth, we might have quite low pressure acting on the rock, but heat from magma. Or we could, at a plate boundary, for example, have very high pressure and actually not a great deal of heat. So we need to think about those 2 key features, those 2 key factors together. Now, the third thing we can throw into the mix here is, I apologise for the cartoon here, or the images here, it's the parent rock. What was the original rock like? A metamorphic rock was something else before it became metamorphic. The composition of that parent rock will have an effect on the type of metamorphic rock you get. For example, a marble was a limestone. You can't make a marble from a mudstone. It's the wrong ingredients. So there's a huge variety of parent rocks to consider, as well as the heat and pressure. And the final one we need to consider is time. How much time were these rocks subject to these different processes? Now we're going to focus particularly on factors 1, 2, and 3 here. Factor 4 is definitely an issue, but it's something we get to perhaps at a more advanced stage of our geological studies. Okay. Have a go at the questions at the bottom of page 4. Think about the rocks that we've been looking at earlier in this lesson, as well when we're trying to answer these questions. So, as we see the sunset on the Callanish stones in Lewis, made out of some pretty ancient gneiss, we need to think about all these different factors and how they influence the properties that we can actually see in the rocks that have been metamorphosed. Next time, we need to consider some of the ways in which rocks actually get metamorphosed. But that's for another lesson. I'll see you then.